Welcome to Comfort Learn classes. In this video, I will solve the remaining questions from 5.3 from this continuity and differentiability. So in the previous video, we solved till question number 8. Here, I will solve from question number 9 to question number 15. So here, these questions are similar. In all these questions, we have inverse trigonometric functions. And we know the derivative of inverse trigonometric functions. If I take f of x is equal to cos inverse of x, then the derivative is minus 1 divided by root of 1 minus x square, and here fine. So but if you see here, we don't have just sine inverse of x here, right? If it is just sine inverse of x, we could have directly taken the formula, but here we have different expressions, so you can't use these formulas here to find the derivative. Then what is the better option? Okay, let's solve question number 9, that is y is equal to sine inverse 2x divided by 1 plus x square, right? So here we can't use the direct formula. Then the other option is making a substitution. So what substitution need to be made here, right? So what is the substitution that is required? So here let me add one more formula here. This sine 2a can also be written as 2 tan a divided by 1 plus tan square a. Okay, sine 2a can also be written as 2 tan a divided by 1 plus tan square a. So now if you see the given expression here, if you can't use the direct formula, then if you want to make a substitution here, so you better go through the double angle formulas. So definitely you will find one expression similar to the given expression here. So now if I take so if you want to get it in the form of 2 tan a 1 plus tan square a, you need to make a small substitution, that is x is equal to tan of a. So if I take x is equal to tan of a here, so what we get? We get y is equal to sine inverse, as it is, 2 times tan of a whole divided by 1 plus tan square a. Okay, again why we need to make a substitution of x is equal to tan a here? Because if I take it as tan a and then use this double angle formula, this can be written as sine of 2a, right? If you use the double angle formula, we can write this expression as sine of 2 times a. Then this sine inverse and then sine will be cancelled out. Then we will get rid of the inverse trigonometric function, right? So the main objective of this substitution is to remove this sine inverse. So right, so what we get here? So here this sine inverse will remain as it is, and then this 2 tan a divided by 1 plus tan square a here, 2 tan a divided by 1 plus tan square a can be written as sine of 2a, right? So what we get here? Sine of 2a. In the next step, we can just cancel out these two. So if you cancel out these two, you are left with 2 times a, right? So now this is my y here, 2 times a. So now next, what is this a here? If I take x is equal to tan of a, can I take a as, this a can be taken as tan inverse of x. Okay, what is a here? A is 2 times tan inverse x. Now you can find the derivative from this step here, right? So my dy by dx will be this 2 as it is, and then derivative of tan inverse x. What is the derivative of tan inverse x? We don't have it here. The derivative of tan inverse x will be 1 divided by 1 plus x square, right? So this is the required derivative of the question number 9, that is y inverse 2x divided by 1 plus x square, right? So what is important here? You need to just remember this substitution, right? Okay, before that you should by heart all these double angle formulas, and in exam definitely will get one of these questions, and sometimes these questions are asked in competitive also, just like KCET, right? You may get such questions in KCET, so better you remember all these formulas, right? So fine, let me take one more question from here. Which one? Let me take the second, before that, no, let me take question number 11. We'll solve question number 10 later. First let me take question number 11. So what is question number 11 here? Y is equal to, we have cos inverse 1 minus x square whole divided by 1 plus x square. Okay, again, instead of going for the direct derivative, make a substitution, reduce it to the simple form, and then find the derivative. Next, here what substitution need to be made here, right? So if you just go through the double angle formulas, again we don't have that expression here. You can just check your formula sheet. We know that cos of 2 theta or 2a can be written as cos of 2 theta, or 2a can be written as 1 minus tan square theta whole divided by 1 plus tan square theta, right? So now you can just compare these two, right? Now how can we get this? Just by making a small substitution, x is equal to tan of theta. If you just take x is equal to tan of theta, then this whole expression can be written as cos inverse 1 minus tan square theta whole divided by 1 plus tan square theta. Again, we need to make a substitution because of this cos 2 theta. Because if I take cos 2 theta here, this cos inverse and then cos will cancel out, and then we will be left with just 2 times of theta, right? So fine. So now here cos inverse as it is, this can be written as cos of 2 theta, and cos inverse cos, these two will cancel out. Now y is equal to just 2 theta, right? Again, what is theta? From here you can write theta as tan inverse x. Okay, so 2 times tan inverse x, that is my y. So dy by dx will be equal to, from this step, 2 constant as it is, and then derivative of tan inverse x 1 divided by 1 plus x square again, or you can just write 2 divided by 1 plus x square, right? So just remember this one, cos of 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. Otherwise I will share the formulas in the link below, right? In the description you can just go through the formulas, right? Fine, let me take one more question. Which one? Now you can take this question number 10, right? Okay, so what is question number 10? Question number 10, y is equal to, here we have tan inverse of 3x minus x cube whole divided by 1 minus 3x square. All right, so now see here, I will give you a hint here, right? Best, or you can just take it as a note. You need to better remember this one. When we have tan inverse of some expression here, the first thing is you just go through the formulas of tan of 2 theta and then tan of 3 theta. Okay, first thing you should remember this one. If it is tan inverse here, first you should go through this, okay, and then compare the expressions, right? So here as we have cube and then 3, we don't need tan of 2 theta here. Then what is the other option? Tan of 3 theta. And if you just go through the formula, tan of 3 theta can be done as 3 times tan theta minus tan cube theta whole divided by 1 minus 3 tan square theta. Fine. So now we just compare these two, this with this expression. So both are similar. Yes or no? 3x, 3 tan theta, x cube, tan cube, 3 times x square, 3 times tan square theta. So again here you need to make a substitution of x is equal to tan of theta, right? So then this will reduce to minus tan cube theta whole divided by 1 minus 3 tan square theta, right? So tan inverse as it is, 3 tan theta minus tan cube theta, this is replaced by just tan of 3 theta. Again these two will cancel out, you are left with just 3 theta, and then 3 into what is theta? Same, theta can be written as again tan of inverse x. Okay, tan inverse x. So instead of 2 in the previous question, here we got 3 into check dy by dx is equal to, this is my y, which is 3 here, dy by dx is equal to 1 divided by 1 plus x square. So 3 divided by 1 plus x square. So this is my derivative. Again the formula, you need to just remember double and triple angle formulas. You can solve any question out of these. So let me take question number 14 directly, right? Because other questions you can make a direct substitution from the double or triple angles, then you can solve. But here question number 14, if you take, it is a bit different from the previous questions. So here question number 14, which is equal to, let me take y is equal to sine inverse, y is equal to sine inverse 2 times of x root of 1 minus x square. All right, 2 times of x root of 1 minus x square, right? So what we have here, sine inverse. So obviously what we need either sine 2 theta, sine 3 theta, whatever, right? So let me just take sine 2 theta first. So what is sine 2 theta? 2 times sine theta dot cos theta. Okay, utna simple to nahi hai na. This is not like just x and then one more term so that you can make a direct substitution. So here we have x and then a root of 1 minus x square, right? Now how can we get this sine theta cos theta from here? Okay, one thing is you can directly make a substitution of x is equal to sine theta. कर सकते हैं ना? If you just compare this with this expression, you can see here this x can be taken as sine theta. But how can we get cos theta? How can we get cos theta out of this expression, right? So for that, again, the first identity from class 10, that is sine square theta plus cos square theta is equal to 1. So then cos square theta can be done as 1 minus sine square theta, and then cos of theta is root of 1 minus sine square theta. Okay, what is cos theta? Root of 1 minus sine square theta. So now it makes sense here. X can be replaced by sine of theta. So here the substitution required is x is equal to sine of theta. So if I take x is equal to sine of theta, so what we get here? Y is equal to sine inverse 2 times sine theta root of 1 minus sine square theta. Fine. Sine inverse this here 2 as it is, sine theta as it is, root of 1 minus sine square theta can be done as cos of theta. Again, sine inverse 2 sine theta cos theta, sine 2 theta, and then sine and sine will cancel out. Again we are left with just 2 times theta, and 2 as it is, theta here can be done as sine inverse x. Sine inverse x. Fine. So next, find the derivative of sine inverse x, which is equal to 1 divided by, here the last step, dy by dx is equal to what? 2 times the derivative of sine inverse x, sine inverse x, into 1 divided by root of 1 minus x square. That's it. So this is my required derivative, 2 times 1 divided by root of 1 plus x square. Okay, fine. So here these questions are enough. We can easily solve the remaining questions just by making a substitution or by just going through the identities, right? So here, okay, let me just give a hint here. So here 1 minus x square, before that we don't have any tan inverse, sine inverse 1 minus x square. So here again x can be taken as tan of theta for this question. 1 minus tan square, 1 plus tan square. Then here cos, again x can be taken as tan of theta. Okay, so here secant inverse, here 2 times x square minus 1, 2 times x square minus 1, we have it here. So 2 times x square minus 1, you take x is equal to cos of a. If I take x is equal to cos of a, 2 cos square a minus 1 is equal to cos of. Let me solve question number 15. A bit different from the previous questions. Okay, question number 15. If you take y is equal to secant square 1 divided by 2x square minus 1. Okay, 1 divided by 2x square minus 1. So what substitution you will make here, right? So if you just go through this double angle formulas, okay, similar expression, तुम लोगों को बस similar expression find करना है, बाकी सब simple है. So if it is secant square here, I need a secant so that we can cancel out these two. If you want secant, you need cos, right? So you can write it as 1 by cos. What is 1 by cos? 1 by cos can be written as secant square. So you need to just express this term in terms of cos. So that is using cos 2a, 2 cos square a minus 1. Let me take cos 2a is equal to 2 cos square a minus 1. Let's say how can we use this one. So now here 2 and this as cos of a. So let me take x is equal to cos of a. So what we get? Y secant inverse 1 divided by 2 times cos square a minus 1. Okay. Next, secant inverse 1 divided by cos of 2a. Secant inverse 1 divided by cos of 2a. Secant of 2a reciprocal. Secant is a reciprocal of cos, or cos is a reciprocal of secant. You can write it as secant of 2a. Now just remove this. You will get y is equal to 2 times a, or 2 times cos inverse x. Right. Now dy by dx is derivative 2 into derivative of cos inverse x. What is derivative of cos inverse x? Minus 1 divided by root of 1 minus x square. That's it. Right? So this is my required derivative. Hope this video helps you to find the derivative of inverse trigonometric functions with complicated expression.